Hello dear students. In today's class we are going to solve the problems given on series combination of resistances and parallel combination of resistances. In the previous class we already studied what will be the behavior of potential difference and current in a series combination of resistances and in a parallel combination of resistances. Right? Applying those rules we are going to solve the problems. Let us take an example of the diagram which is already given in your textbook schematic diagram. In this figure, what all things are given and what all can be asked, we can assume ourselves. Let us go through this diagram and let us try to analyze the problem here. What it is given, what can be asked in this. First here resistor R1 and R2 of resistances 10 ohm and 40 ohm respectively, they are connected parallelly. Next, resistor R3, R4 and R5 of resistances 30 ohm, 20 ohm, 60 ohm respectively, they are also connected parallelly. Okay, in parallel combination they are connected. Now, look here, I is asked, what is the total current in the circuit, it is asked. Next, total resistance. From this combination and this combination, total effective resistance, how much it is offering in the circuit, that we are supposed to calculate. Now, to calculate this current and to find out this what resistance, total resistance, what methods we are following. First, here this combination we are taking, right? In this combination R1 and R2, accordingly to get this total current, you are not going to add these I1, I2, here I3, I4, I5. If you are doing like this, your sum will be 100% wrong, because this combination, in these two resistors, they are in parallel of course. Here three resistors, they are also in parallel connection. But if you replace this with one resistor as equivalent resistance, and here also these three, instead of these three, if you replace one more equivalent resistance, this equivalent resistance and this equivalent resistance, they are in series connection now. They are not in parallel connection. Because we have already studied in a parallel combination of resistances, how are those resistances they are connected? The two ends of a resistor, if they are directly connected to the terminals of the battery, then we can say it draws the same potential difference. Then it is in parallel connection, we can say. But in this case, if you see here, this combination, let us take this as an equivalent resistance. One more, that resistance is ends. If you take one end is connected to the battery, the other end is connected to this equivalent resistance now. Means what? They are in series connection. In this case, we cannot calculate the current. To get the total current, we cannot go on adding I1, I2, I3, I4, I5. We cannot add it all. Then how to calculate them? In order to calculate that current, we know potential difference, it is already mentioned here, that is 12 volt. Total potential difference, it is given. Then we need to find out the total resistance or effective resistance in the circuit. This total resistance and total potential difference, this gives us what? Total current in the circuit. Then how to do that then? Let us try to solve it here then. First, what is given we will write, that is potential difference, it is given, that is 12 volt. R1, R2 they have given. So let us find out this combination, equivalent resistance, let it be R dash we will take. If it is R dash, total resistance of this combination, this can be found out like this. Instead of writing 1 by RP, we shall write here 1 by R dash. This will be equal to 1 by, here this will be R1 plus 1 by R2. Now 1 by R1, R1 is how much? 10 ohm plus R2 is how much? 40 ohm, 1 by 40 ohm. After adding this, how much do we get here? LCM, it will be 40. 4 plus 1, 5 ones, 5 8s. So 1 by 8 ohm we are getting. 1 by R dash will be equal to 1 by 8 ohm, means what? R dash will be equal to 8 ohm. Right? One we got. This combinations, resistance, equivalent resistance we got now. Let us come to the second one. Let us take this equivalent resistance as R double dash. R double dash if you take, this will we will get like this, how 1 by R double dash equal to 1 by R3 plus 1 by R4 plus 1 by R5. R3, R4, R5. Let us substitute those values now. 1 by R3. R3 is 1 by 30, it is 30 ohm, plus 1 by R4, it is 20 ohm, plus 1 by 60 ohm, it is 60 ohm, R5. After taking LCM, 60 LCM, here 30 into 2, 20 into 3. This becomes 2 plus 3 plus 1. This will be equal to 5 plus 1, 6. 6 divided by 60. 6 ones are 6 tens are. So how much we are getting here? 1 by 10 ohm we are getting. So 1 by R double dash is equal to 1 by 10 ohm. This can be written like this. R double dash is nothing but 10 ohm, it is 10 ohm. Okay. Now effective resistance, if you want that effective resistance, let us write like this one. Effective resistance is equal to R dash plus R double dash, right? R dash is how much? We already calculated. How much it is? 8 ohm. 8 ohm plus R double dash. How much it is? R double dash 10 ohm. 10 ohm. It gives us how much value? 18 ohm. Effective resistance in the circuit is how much? 18 ohm. And potential difference, total potential difference is how much? 12 volt. Then by applying Ohm's law, we can calculate the current easily now. That is, current I is equal to total potential difference divided by effective resistance. Let us write this as effective resistance. Potential difference is how much? 12 volt. And effective resistance is how much it is? 18 ohm, right? Now here 6 2s are 6 3s are 2 by 3 volt and ohm we got. This after dividing this, how much do we get here? 2 3, if you take 0.36 are 18, 2 remains, point is there already, 0 3 6 are 18, means what? It continues same here, 0.66666 it comes. After rounding off, we can get this as 0. This is 6, we shall round it off to 7 now. So what do we get here? Current will be 0.67 ampere. See here. So current is 0.67 ampere. This is how we can calculate the current in the circuit. Just you can see this combination separately we calculated this resistance and this resistance. Okay, equivalent resistance we calculate separately. Then since these are in series, we have added here effective resistance. By adding these two, we have got here, that is 18 ohm. Okay, next by applying Ohm's law, what we did? Potential difference, it is already given. When it is divided by this effective resistance, we are getting how much? The current in the circuit, it is 0.67 ampere. This is how we can solve. In the next class, we shall continue with next problem, which is already given in your textbooks.